Alright, well I should have kept it recording because you can see here we still have the noise, but as soon as I stop measuring the output, we get a nice signal. Of course, I'm not triggered on it. So let's see if I trigger. I'm going to put that guy there. There you go. So we get a nice reading of the signal. No, that's what we want to see. But as soon as I measure the load, which I'm coming in now, I'm actually, before I had a wire coming out, I'm actually going to go straight to the resistor, and we're back to that nice choppiness. Now before I had my amp meter in series, let's go ahead and see if I hook the amp meter back up, if it will give us the reading we want. So give me a few seconds. That goes here. Yeah, I should have had this guy already hooked up, shouldn't I? Alright. Sorry, working back here in the back. You get to see a nice nasty waveform. Disconnecting the load. Alright. And alright, amp meter is in line. What do you know? If I hook up my amp meter, which I have to put in series, we get a nice steady line. And right now at 20 kilohertz at an amplitude of 20 millivolts, and that's 20 millivolts peak to peak, which, you know, just for recording, let me go ahead and drop onto that. I'm going to go ahead and come across here. That's my input signal. So let's go ahead and zoom in. Oops. Alright. I'm going to take the DC, I'm going to AC couple it. And then I'm going to add a measurement. Let's see here, peak to peak. It won't be. Alright. Hard to read. I'm going to pause it. And right now, that's, oh, just got a text. That's odd. Getting a 71 millivolt peak to peak. Huh. Last time I measured this, I was getting well, 20 to 20 should give us a 40 millivolt if there was just a 20 millivolt span. Kind of curious as to why. Let me go ahead and let me see if I stop measuring. Okay. Go back to B. All right. Ooh. I'm just gonna let it shift. Right now I'm measuring 35 millivolts. That's because I disconnected the input to the base. It looks like that was giving me an erroneous reading. Oh no, back down to it again. Oh, you gotta love this electrical engineering stuff. Alright, so I don't know what was triggering it right now. Maybe I paused it on a spike to spike and I got more than I thought. I'll replay the video to see if I see a different waveform. Alright, so I'm inputting a 20 millivolt amplitude. That's not peak to peak. Sorry, I misspoke. So I should be outputting a 40 millivolt peak to peak. Right now I am at 33.99 millivolts after that 50 ohm transistor, 50 ohm resistor. So we're going to go back to the output. I'm going to go, right, I stopped capturing for that reading. So now I need to make sure that I change to here. We take off the input signal, and where is my, oh yeah, there it is. Go to load, there's the load. So we're back to the input signal to the CC stage, green. The yellow is the output stage to the actual output of everything across the load. All right, next step, lab-wise. We're going to go ahead and calculate the gain. So at the input, let me do a peak-to-peak across A. Add measurement, A, peak-to-peak. All right. And what I'm going to do is I'm going to, right now I have it on DC because the base is obviously has a DC bias, has a DC offset. I'm going to go put the AC couple so that way I can get a better peak-to-peak on both of them when I increase. All right. So we had a whoops, wrong way. Let's go to 20. There we go. So you got a little bit of jitter there, not too bad. Chalk that up to my instrumentation. So if A is peak to peak at 3.028 volts, and we had an input of we said 38 millivolts, or was it 33? Either way, my voice is on there. We'll go with 38 first, then 33. If we do a quick calculation on the calculator, let's see, that's 3.091 divided by 0.038. That gives us a gain of 81. And let's see if we do that with 33. That gives us a gain of 93.6. I felt like I did better than that before. No, anyway. We'll go ahead and take those results. Those are still nice results. The difference between the two, the input is 3.028. The output is 2.997. So that gives us a gain of 9.1. And that gives us a gain of 90.96. So we're actually achieving, at least on the second stage, the voltage gain. We're coming in a little bit under on the gain of the output stage. I believe I've gotten into the hundreds. I'll have to revisit that calculation, but still, even if it's around 91, 95, that's still a pretty good gain for some of the problems that we've had in the past with our circuit. Moving on. Doing verify gain of each stage, remove load, and verify the output. All right, so if let's remove load. Load is removed. Right now I have stopped capturing. Let me, I'm just hooking up. All right, and boom. It's nice and jittery. Oops, wrong way. Let's hit 10 volts. Let's hit 10 volts. Okay, not a very good waveform. There's that noise. This is without the load there. So I'm just going across that capacitor. What I'm going to do is I'm going to take this across my amp meter, see if that will clean up the noise a little bit, because there's some internal impedance to the fluke. See if that helps us. And it does. All right. So right now, peak to peak wise with the load is almost exact. On the second stage, it's almost exact. 3.09 2 on the input, 3.09 on the output. So with the load removed, we're pretty much, exactly where we expect to be. I'm going to go ahead and keep triggering that, and we're going to zoom in. Let's see, 5 volts. Oh, can I do 2? Yeah, let's do 2. We'll go 2 volts each. All right. And when I stop capturing, my output to input still stays the same. So I am going now to connect I have my own little decade resistor. I'm going to go ahead and drop that in. See if we can get and this is 100K, by the way. So nice large swing. It's didn't go inside my breadboard very well. Let's see if I can. Alright, so there's 0 ohms, and we want half the waveform. So let me go ahead and put some rulers up there for half the waveform. Whoops. Half the waveform. Alright, there's that ruler. Here. This guy's being a pain in the butt. Huh. Okay. That's better. Okay. I had one of the leads of that potential